All right, hello. We are here to work on a video walkthrough of LT8 inverses practice quiz number 2. Let's start with standard 8.1, determining an inverse values given a table. So for the inverse, what have we learned? When we do an inverse, the x and y flip, the domain and range flip. So the original x values in our table over here, our original x values become our new y values. So all we have to do is just flip the table. 0.5, 3, and 10. If we flip the x values to the y, our old y values for f of x become our x values for f negative 1x. So we get negative 18, negative 8, 1, 6, and 20. The original y values become our new x values. The original x values become our new y values. That's it. All right, let's move on to 8.2. How do we do an inverse from a graph? Now, for a graph, the key is, what is the line of symmetry? The line of symmetry that we are looking at is this line right there. That line right there is our line of symmetry. It is the line y equals x. All right? So basically what we're going to do is we're going to reflect the points over that line. So if this line right here is, let's call this f of x, our inverse function gets flipped over the line of reflection. So this point flips over here. 0, negative 4 becomes negative 4, 0. 5, comma, negative 5 becomes negative 5, comma, 5. And then we just draw it in. So it looks kind of like that right there. And that is f negative 1 of x, inverse f of x. And that's it. There we go. All right, let's move on to standard 8.3. Okay, determine the inverse of each equation below. And this is the key part. Be sure to specify if there are any restrictions on the domain of the inverse equation. That's going to come up here at least once. So we'll make sure we get there. For the first one, for each one of these actually, your main strategy, see how it's like y equals 5x plus 3? You flip the x and the y. So we'll put x there equals 5. And we're going to flip. So instead of x, we're going to put y here. Now our goal here is to solve for y. Get y by itself. That will give us our inverse function. Undo it one step at a time. Add 3 to both sides. We get x plus 3 equals 5y. We want to get the y by itself. So how do we undo this? What's the opposite of 5 times y? Divide by 5. So we get x plus 3 divided by 5 equals y, which is the same as inverse f of x. That is our inverse. Now we think about this. This is a line. This is a line. No domain restrictions required. All right, let's do the next one. So now we've got g of x equals 3 over x minus 2 plus 5. So let's flip the x and the y. So x equals 3 over y minus 2 plus 5. First step, let's subtract 5 from both sides. So I'm going to get x minus 5 equals 3 over y minus 2. Now, it's tough when there's a fraction there. Fractions do make it hard. Fractions definitely make it hard. So in this case, let's do this. I'm going to multiply both sides. Well, yeah, I'm going to multiply both sides by y minus 2. When I do that, cancels on that side. And I'm going to get equals 3. And on this side, xy minus 5y minus 2x plus 10 equals 3. Again, this doesn't really seem like I'm getting somewhere, but if we can get just the y pieces over here, I bet we can factor stuff out. So I'm going to add 2x and subtract 10 from both sides. So that's going to give me xy minus 5y equals 2x minus 7. Now, what do you notice? What's the greatest common factor between these two terms? The greatest common factor is y. So if I factor a y out, I get y times x minus 5 equals 2x minus 7. Get y by itself, divide by x minus 5, divide by x minus 5. I'm going to find that my final answer, inverse g of x, equals, because now y is by itself, 2x minus 7 over x minus 5. Okay, great. Let's look at the third one. I should box that one right there. For the third one, again, start the same way. Flip x and y. So x equals 3 times the square root of y minus 5 plus 4. So I'm going to subtract 4 from both sides. So x minus 4 equals 3 times the square root of y minus 5. Again, my goal is to get that y by itself. I'm going to divide both sides by 3. So x minus 4 divided by 3 equals the square root of y minus 5. Undo the square root by squaring both sides. So I'm just going to leave it squared like that. X minus 4 divided by 3 squared equals y minus 5. The square root's been canceled. And then add 5 to both sides. So that means my final answer here, h inverse h of x equals, because now y is going to be by itself, x minus 4 over 3 squared plus 5. Now, for this one, think about what happened here. We have a square root function. That square root function, our original h of x, looks something like, I don't know, like that. Okay, so that's h of x. If we think about our line of reflection right there, right, this inverse h of x is a parabola. But a parabola would have two parts to it. In order to be an inverse, we only want that part right there. Okay? We only want the part that would reflect on a graph. So we only really want half of it. Okay? We only really want half of it. So in this case, think about what the range is for this one. The range for this equation right here is that y must be greater than or equal to 4. Why? Because whatever comes out of this part must be at least 0. 0 plus 4 is 4. The lowest possible number is 4. This point right here is at 4. When you flip that over, this point, whatever comma 4, becomes 4 comma 0. So our x values can only be greater than 4 in order to be a true inverse of this original function. We don't want both halves of the parabola. Only the part of the parabola where the domain, the x values, are greater than 4, because that forms the reflection. So we have to include a domain restriction that x must be greater than or equal to 4. That's where that domain restriction comes into play. Generally, you want to be careful of it when it comes to square root functions. That's a big one to be aware of. All right, standard 8.4. Let's finish this off. Use function composition to prove or disprove the equations below are inverses. What does that mean? That means that m of p of x equals x. All right. Well, what does that mean? That means p of x is now our input for m of x. So I'm going to rewrite m of x as, instead of x minus 1, all right? So I'm going to take this p of x, and I'm going to substitute it in for m of x. So I'm going to put the cube root of x plus 5 minus 1, and then I'm going to replace that with this x, so then fill in the rest of it. Minus 1 cubed. Oops, should make that blue to be easier. Plus 5. So all I did was I took p of x, substituted in for x. Let's simplify this a little bit. The cubic root of x plus 5, can't really deal with that yet. X plus 5 minus 2 plus 5 cubed. Now, the question is this going to work out to be just x? Is this going to simplify to just equal x? Here, if you think about what's going on, we're going to cube this. So we're going to have this times itself times itself. Great, that's going to give us an x plus 5. But then minus 2 cubed, well, that's going to give us a negative 8 at some point. There's no way we're really going to be able to cancel out a 5, negative 8, and a plus 5 to equal 0. It's not going to happen. So this does not work. You can go through and actually do it, or you can think ahead and think about how this piece would expand out. Okay. Let's try the other side. When you do it on the real quiz, you want to make sure you do both of them. Both orders must work. What do I mean by both orders? P of m of x must also equal x. You want to make sure you check both. Just because one works doesn't guarantee the other works. Okay, so we know the first one's no, so we know this one's not an inverse, but it still makes sense to try. Because what if we had done the opposite order? All right, so what we're going to do is we're going to take m of x and substitute it in to p of x. So our question is, does the cube root of, and I'm going to replace x here with m of x, x minus 1 cubed plus 5. Now, keep going with p of x plus 5 minus 1. Does that equal x? Simplify it a little bit. The cube root of x minus 1 cubed plus 10 minus 1 equal x. Now, we could expand this all out, x minus 1 cubed. All right, we know how to expand that. X minus 1 cubed is like x minus 1 times x minus 1 times x minus 1. We could do that if we wanted to. Sure. We would have x cubed. There'd be some other pieces in there. And we also end up with a negative 1. Are we going to end up with a perfect cube under here that's going to cancel things out? No, it's not going to happen. It's not going to work. So again, you could do the work to expand all the algebra out, or you could think critically about what's in here and kind of work through it and think ahead about what might happen. So neither of these, when I compose the functions together, equal the original input. They don't undo each other. So in this case, the answer is no. M of x and p of x are not inverses. Great, there we go. That is LT number 8, practice quiz number 2. Good luck.